Welcome to Klein's Geometry. Today we're going to look at Lesson 8-2, Trigonometric Ratios. You watched the Patrick video, it was a 3-minute long video, and you learned about the trig ratios, the sine, the cosine, and the tangent. An acronym to remember them is the word SO, CA, TOA. And that stands for the sine of the angle is the opposite over the hypotenuse. The cosine of the angle is the adjacent over the hypotenuse. And the tangent of the angle is the opposite leg over the adjacent leg. So if you remember the word SO, CA, TOA, and you pronounce it just SOA, you will be able to remember your three trig ratios. Now, in a special right triangle, remember the two special right triangles are 45, 45, 90 and 30, 60, 90. In a 45, 45, 90 triangle, the two angles, or the two legs, are congruent, and the hypotenuse is the leg times the square root of 2. A ratio you should have memorized in Chapter 5, and if not, do it now. There's some review videos on the Moodle that you can go to if you need to refresh yourself on this. In a 30, 60, 90 triangle, the ratios are the short leg is some length, and the hypotenuse is twice that. The long leg is the short leg times the square root of 3. So again, ratios to memorize. If you remember these two, you can find the sine, cosine, and tangent of 45, 30-degree, and 60-degree angles. All you need. Now to find them, looking at a 45-degree angle, I would say this going across was the opposite leg, this was the adjacent leg, and this, of course, is the hypotenuse across from the right triangle, or the right angle. So now if I want to find the sine of 45, so opposite over hypotenuse, so I will write x over x squared root of 2. Now, I know any number over itself is 1, so I have 1 over square root of 2. That's good as far as it gets, but as you just were refreshed on with Patrick, you know we usually rationalize the denominator. So I'll multiply that by square root of 2 over square root of 2 to get square root of 2 over 2. 1 times square root of 2 and square root of 2 squared. So there's my final answer for the sine of 45. Now if I want the cosine of this 45-degree angle, I've got the adjacent leg over the hypotenuse, which, because of the 45-degree symmetry, is going to give me exactly the same thing. The tangent of 45 degrees, so CA, TOA, is the opposite leg over the adjacent leg, so I have x over x, and that, of course, reduces to 1. So we've got the sine and the cosine, square root of 2 over 2, and the tangent is 1. To look at a 30, 60, 90 triangle, let's just look at the 30-degree angle. After that, I'm sure you can do the 60 on your own. The leg opposite 30 is this one, and the leg adjacent to 30 is this leg. The hypotenuse is across from the right angle, as it always is found. Sine of 30, so opposite over hypotenuse, so I'm going to put x over 2x. In this case, the x's will cancel out. I have 1 over 2, because x over x is 1. The cosine of 30 degrees, that's going to give me the adjacent leg, x squared root of 3, over the hypotenuse, 2x. Well, the x's are going to cancel out. That equals 1, and I'm left with square root of 3 over 2 for my cosine of 30. The tangent of 30 degrees, so CA, TOA, the opposite over the adjacent leg, x over x squared root of 3. And those will reduce to 1 over square root of 3. Now I need to rationalize my denominator, and that gives me square root of 3 over 3 for that answer. So hopefully you can see how this is done. Use your ratios, use the special right triangles, and you're going to be fine with those. Now, to calculate ratios, because all right triangles of the same angles are similar, they'll have the same ratios, you're using your calculator. Those are all built into your calculator, and but if you're using, there's two ways to measure angles, in degrees and radians. So if we're going to do it in degrees, we need to make sure we're in degree mode. So the first thing we're going to do is turn on our calculator, go to mode. Notice we have radian mode as a choice, and we have degree mode as a choice. So when you're, and I just used my arrow keys down and over. So once I've got the degree I want, I'm going to press enter. And now that's set in degree mode, and I'm going to go to second quit to get back to my work screen. Now we've calculated the cosine of 30 exactly to be square root of 3 over 2. But we're going to look, and we're just going to get the rounded answer. When we round these ratios, we'll round to the hundredths place. So I'll just press the cosine. Notice cosine, tangent, sine here, of 30. Get that so you can see what I'm doing. Cosine of 30. I'll press, and I'll close my parentheses and press enter. Well, remember, if we're going to round to the hundredths place, we look at the thousandths. That's 5 or above, so we buff this up, 0.87. Now if I want to find the sine of 8 degrees, I've got my sine, cosine, and tangent here. I'll press sine of 8 and enter. And again, I want to round to the hundredths place. I look at this, it's more than 5, so I bump this up, 0.14. Sine and cosine will always be a number less than 1, okay? 1 or less, excuse me. The tangent of 12, now tangents can be larger than that, so we'll look at the tangent of 12 degrees, and we've got 0.21. Notice that this number is not greater than 5, so we're not going to round that up, okay? So that's all you're doing when you're finding trig ratios. Make sure you're in degree mode. Now, the next thing we're going to do is use these ratios to find length. And you have to be kind of analytical on this. Let's say we want to find DF. We want to find this length right here. Well, the first thing I'm going to do is I'm going to identify which sides are which in my triangle. So right angle, across from the right angle, I know is the hypotenuse. I have this angle to work with, so in relation to this angle, DE is the adjacent leg. And FE across from it is my opposite leg. So that's the first thing you do. That way you know what you're going to do. Then you think, what do I have and what do I want? You need to know those two things to write a ratio. So I look here and I have the opposite leg. I want DF, which is the hypotenuse. So I think, what are my choices? So, ka, toa. And the opposite over the hypotenuse is my sine ratio. So I'll write the sine of 51 degrees equals the opposite leg, 17, over the hypotenuse, which is FDF. Now to solve this, I need to multiply both sides by DF first, and that'll cancel out, but I have DF times the sine of 51 equals 17 now, and I want DF alone, so I'll divide by the sine of 51. That'll cancel out, because any number over itself is 1. So I know DF is equal to this exactly. So I'm going to get my calculator out, and I'm going to plug this into the calculator. 17 divided by the sine of 51 degrees. Make sure you're in degree mode. Now I hit enter, and I see, rounded to the hundredths place, 21.87. And they gave me meters, so I need my units in the answer. So that's how you're going to do it. You're going to identify what's your opposite leg, adjacent leg, and hypotenuse in relation to this 51 degree angle. Because now, if you had an angle over here, this would be the adjacent leg. Okay? Once you've got that, you figure out what do you have, what do you want, decide which ratio to use, and then you just plug it through. So hopefully that helps, and please watch the next video to see one more example and example 5.